Hi, my name's Tom. Welcome to another video of ATPL tips. This is video number 3 in my short series on altimetry. Altimetry can be really confusing. There's QNH, QFE, QNE, ISA and ISA deviation, pressure altitude, true altitude, density altitude, height and elevation. It's enough to make your head spin. Unfortunately though, for all of us, altimetry comes up in GNAV, it comes up in instruments, and it'll come up in your MET exam as well. So it's a really good idea to try and get your head around the subject as early as possible within your ATPL studies. In the first video, we looked at some of the basics of altimetry theory. The second video, we took a slightly deeper dive into density altitude and true altitude, and we did some simple-ish exam questions. Now we're going to dig straight on into some more exam questions, and they're going to get a little bit trickier. As ever, to play along at home, you're going to need a pen or pencil, you'll need an eraser probably, and you'll need a calculator. And if you've seen video 2 already, you'll know that I've made some handy dandy worksheets for you to print out and save you having to do a drawing every time because I'm nice or sad. Ask my wife. But print some of those off if you've got ink in your printer, and let's get on with it. So here we go. The question says, an aircraft is flying at flight level 100. The outside air temperature is ISA minus 15. The QNH given by a meteorological station with an elevation of 100 feet below sea level is 1032. Calculate the true altitude of this aircraft. Okay, not too much going on there. You'll know from the previous video that I'll put the steps up on the screen to help you work out how to get your head around this question. The first thing that we'll always want to do is look for the ISA deviation, and this question's really nice. It just tells us that we are ISA minus 15. Awesome. The second thing that you might have noticed within this question is that we're dealing with an airfield or a meteorological station that's 100 feet below sea level. Well, that means that on our sketch, where we've got the portion above sea level, actually this time we're not above sea level at all, we're below sea level by 100 feet. So make that annotation on your chart. We're ISA minus 15 and our QNH is 1032. Okay, so here we are flying along, and we're at flight level 100. Well, remember that the air pressure decreases as altitude increases. So because at sea level it's 1032, that means that our QNE level is going to be higher than that because 1013 is higher than 1032. So our ISA datum is above sea level. So 10,000 flight level 100 is measuring the distance between our ISA datum and our current flight path. Now you'll remember that the formula for true altitude is indicated altitude plus a temperature error correction. So the first thing that we need to do, having worked out our ISA deviation, is to convert our flight level, in this case flight level 100, to a pressure altitude. So the way that we do that, we know that we've got 10,000 feet between our ISA reference and our current flight path, and we know that our ISA datum is above sea level, so we need to work out the distance between ISA and sea level. So we can do that by subtracting ISA from our current pressure. So we can take 1032, subtract 1013, and that gives us a difference of 19 hectopascals. So 19 hectopascals, I'm going to use 27 feet as the measure per hectopascal. I feel like it's more accurate than 30. The reality is, and I've said this in a previous video, in virtually all of my exam questions, and I can only speak to my own experience, but in virtually all of my exam questions, save for maybe 2, they told me what reference to use. It would always say use 27 feet or 30 feet. I'm going to use 27 because it feels more accurate. We'll see how this goes. So 19 hectopascals times 27 feet per hectopascal 19 times 27 is 513 feet. So the height between our ice at datum and our pressure at sea level is 513 feet. So our indicated altitude is 10,513. Cool. So we can start assembling our true altitude formula down here. True altitude is 10,513 plus. Now we need to do the temperature error correction. You'll remember from the previous video that the temperature error correction is done to the parcel of air between your aircraft and the surface that you're flying over. Most of the time that means that you take your indicated altitude and you subtract the height or the elevation of the station that you're flying over. However, in this case, because the station is below sea level, we're actually going to have to add that on because it's 100 feet further away from us than sea level. I think that makes sense. So our temperature error correction formula, if you remember, is 4 times, and 4 is a constant, 4 times our the height above the surface, which in this case is 10,613, because we've added 100 to the indicated altitude, divided by 1,000, because we only want the number of thousands, times our ISO deviation, which in this case is minus 15. So we can take that formula, we can actually rewrite it as 4 times 10.613 times minus 15, and that will give us minus 636.78. I'm just going to round that to minus 637. And we can now plug that temperature error correction into our true altitude formula. And that means that we're looking for 10,513 minus 637. So 10,513 minus 637 gives us 9876 as a true altitude. Well, from the options that are available to us for this question, it looks like answer B is probably the right answer at 9,900. A is 10.6, C is 11.2, and D is 9.4. I'm going to say that 9.9 is a solid guess for this one. How have you found this question so far? Does this make sense? If it doesn't, then by all means go back and start maybe halfway through video number 2 of this series to see some slightly easier questions. Okay, let's see if answer B is correct. Boom, excellent. If you want this question on AvExam, then you can look it up. Its question number is 53168. If you want it on ATPL questions, it is question number 619383. I couldn't find it on ATPL GS, and it's probably also on Bristol as well, but I don't have access to the Bristol question bank. If you do and you find this question, I'd love it if you could put the question number in the comments below for me. Thank you. Okay, question number 2. An aircraft is flying at flight level 150 with an outside air temperature of minus 30 degrees above an airport where the elevation is 1,660 feet and the QNH is 993. Calculate the approximate true altitude. Okay, this question is quite similar to the previous one. Get yourself a fresh sheet of paper and let's go. So step number 1 is, of course, to work out the ISO deviation. This time they've given us the temperature. They haven't told us the ISO deviation, so we need to work that out ourselves. The formula is 15, which is the ISO standard at sea level, minus 2 times 15, because it's 2 degrees per 1,000 feet, and we're at 15,000 feet, which is the same thing as saying 15 minus 30. So the ISO standard temperature should be minus 15 degrees C. Actually though, we have been given an outside air temperature of minus 30 degrees. So what's the difference between those two? Well, today we are 15 degrees colder than it should be according to the ISO standard atmosphere. So that means that we are ISO minus 15. Okay, right, now let's populate the rest of the page. We are flying along at, what, 15 or flight level 150. Our QNH is 993. And the elevation of the airport that we're flying over is 1,660 feet. Okay, so the QNH is lower than 1013, and as you remember from the previous question, air pressure decreases with altitude, which means that our QNE level is going to be below sea level. So we can ignore this one. So our QNE is down here, so our flight level reference of 15,000 feet is actually in reference to this, this plane, the 1013 plane down here. So in order to find out our indicated altitude, what we need to do is work out the difference between our 1013 level and our 993 hectopascal level in order to work out what our indicated altitude would be. Well, 1013 minus 993 is 20, so 20 times 27 feet per hectopascal will give us 540 feet. Plug it into a calculator if you don't trust me. So our actual indicated altitude is going to be our flight level minus 540 feet to give us this component, our indicated altitude. So it should be 14,460. Let me see if I'm right. Okay, that's a relief. So indicated altitude today, or in this question, is 14,460. So we can start now to populate our true altitude equation, which is true altitude equals our indicated altitude, 14,460, and that'll be plus or minus a temperature error correction. Now, you'll remember that we only do the temperature error correction for the column of air between us and the surface that we're flying over. We've got an elevation of 1,660, so let's subtract that from our indicated altitude. So 14,460 minus 1,660 gives us 12,800 feet. That's the height of this column of air that we're passing over. So the temperature error correction formula is 4 times 12.8, because we only want the 1,000, so you can divide 12,800 by 1,000, times our ISO deviation of minus 15. That means that if we plug that into the calculator, 4 times 12.8 times negative 15, negative 768. And that is our temperature correction. So we can do 14,460 plus a negative 768, and that will give us 14,460 minus 768, 13,692. Cool. Making a mess of that. 13,692 as our true altitude. Let's have a look at how that compares to the answers on the screen. Well, we've got 13,640, 52 feet away, that's not bad. We've got 15,190, we've got 17,140, and we've got 14,400. I will absolutely say, based on what I've just come up with, that the answer to this question is going to be A, 13,640. Let's see. Okay, good, correct. If you want that on AvExam, you are looking for question number 14597. If you want it on ATPL GS, it is 110458. I couldn't find it on ATPL questions, and you know the drill about Bristol. If you can find it on there, leave a comment in the comments below for me, that would be fabulous. Alright, let's move on to question number 3. The QNH of a station at 2,500 feet is 980 hectopascals. The elevation of the highest obstacle along a route is 8,000 feet, and the outside air temperature is ISO minus 10. When an aircraft en route has to descend, the minimum indicated altitude with QNH on the subscale of the altimeter to maintain a clearance of 2,000 feet will be, and then we've got some options available to us. As always, the first thing that we're going to want to do, get a clean page, the first thing that we're going to want to do is work out what our ISO deviation is. And we know, because it tells us in the question, that we are ISA minus 10. So that's fairly straightforward. ISA minus 10. Happy days. Now, this is a slightly more difficult question. This time we've got an obstacle and we've got a clearance. So the obstacle elevation, and we know that elevation is referring to height above sea level. The obstacle is 8,000 feet, and we have to maintain a clearance of 2,000 feet. We've got a QNH of 980, which means that we're looking at a QNE down here, although I don't think there's anything in the question that asks about flight levels or pressure altitude or anything like that. Okay, so, right, what's the question asking? Well, if you read it really closely, you'll see that it's telling us this time what our true altitude needs to be. It's saying if we are 2,000 feet above this obstacle, in other words, a minimum clearance of 2,000 feet, what does our indicated altitude have to be in order to maintain that clearance? So this time they're giving us the true altitude. So we can start our true altitude formula, except rather than trying to work out what true altitude, we know what true altitude needs to be. So 10,000 feet equals our indicated plus our temperature error correction. They're asking us for the indicated altitude. That's an easy one to skip or to misread. So what can we do? Well, we can do the temperature error correction because we know that the station is 2,500 feet elevation, which means that the column of air that we're flying over is 7,500 feet. So we can apply our temperature error correction, and we know that the formula for that is 4 times, and it'll be 7.5 times minus 10. So 4 times 7.5 times negative 10 gives us minus 300 feet. So it's actually not that difficult. They've just given us bits of information that we're not used to seeing before. So now we can put the minus 300 into our true altitude formula here, and we end up with 10,000 equals indicated minus 300. So that means, if we rearrange the equation, that our indicated altitude equals 10,300 feet. That's actually not that difficult. When you look at the answers available to us on the board, we've got 10,400 as an option. Now, I'll be honest, if you go to look at the comments on AvExam, and by the way, this is question number 99162 on AvExam, there are loads and loads and loads and loads and loads of grumpy people because the explanation suggests the 4% error correction rule, and it suggests doing the 4% error correction for 10,000 feet. It's not taking into account the height above the surface, it's taking into account the whole of the true altitude. There are loads of grumpy people on there saying, well, how can we do one thing for one question and one thing for another question? Ignore all of that because you'll get yourself in a twist. You know the steps to go through, and that is you do the ISA deviation, you do any pressure altitude conversions, you do a temperature error correction, and you add them together. If you know the method, you can get past the dodgily worded questions in the banks. It's, at the end of the day, the banks are based on student feedback, and students will either have bad memories, they might misremember things, and it's also possible that it's been answered incorrectly by the bank on the bank. The most important thing is that when you sit down to take your exam, you know how to do the question. It doesn't matter whether other people are getting their knickers in a twist about an explanation. Do you know how to do it? You know the method, you can work this out, and actually, this wasn't that difficult, I hope. Can you see? I think the only thing with this question that seems particularly difficult is the way that they word it. You have to be very, very careful about understanding that they're giving us true altitude. And I think maybe a drawing like this is really helpful because they're saying you have to maintain 2,000 feet. So if you have to maintain 2,000 feet, well, if that is on our indicated altitude, you know that your true altitude is going to vary slightly, so it must be the true altitude they're giving. Okay, enough waffling from me. Let's move on to the next question. Or let's see if this is right first. Yes, it is. Okay, and as I said, that question on AvExam is 99162. The question on ATPL GS is 110460. And on ATPL questions, 617078. As ever, if you've got it on Bristol, put it on the comments on the video comments below for me, that would be great. Alright, let's move on to the next one. Alright, do you know what? The other thing that you could do is get one of these, get it laminated, and then just use a whiteboard marker and then just wipe it off each time. Alright, next question says, given an aircraft has to fly over a mountain ridge, the highest obstacle, indicated on the navigation chart, has an elevation of 9,800 feet. The QNH, given by a meteorological station at an elevation of 6,200 feet, is 1022. The outside air temperature is ISA +5. Calculate the approximate indicated altitude to obtain a clearance of 2,000 feet. Now, this is interesting because for the first time in our answers we're seeing a range. And before we even start looking at this question, I want to say that I think answer C here, and I've double checked that I haven't made a mistake, but on AvExam this is what answer C looks like, and I think it's wrong. If you look at the way that A, B and D, they step up from a lower number a couple of hundred feet to a higher number, answer C here doesn't really follow that trend, going from 11.9 to 11.2. I think answer C is supposed to be 11.9 to 12.2 and that there's a misprint in the bank, which happens, but let's get into it. So, first thing to do, ISA temperature deviation. We've got ISA +5. So that's easy enough. The QNH that we've been given is 1022. Because of that, it means that our QNE, our ISA reference pressure datum, is above sea level. The elevation is 6,200 feet. And the obstacle has an elevation of 9,800 feet. And we need to maintain a clearance of 2,000 feet. Similarly to the last question, what we're being given here is a true altitude. So we know that our true altitude that we need to maintain is 11,800 feet. That's our true altitude. Incidentally, if that's 11,800 feet, then our height above the surface is going to be 11.8 minus 6,200, and that is 5,600 feet. So we can do a temperature error correction, which will be 4 times 5.6 times our ISA deviation, which is +5, and that gives us 4 times 5.6 times 5, 112 feet. And so that means that our slightly rearranged true altitude formula will be 11,800 feet equals indicated plus 112. And so we can just rearrange the formula slightly. We'll end up with indicated altitude equals 11,800 feet minus 112. So our indicated altitude will be 11,688. Very similar to the previous question in that we have to work out that they're telling us a true altitude, and we have to then therefore find the indicated altitude. So if we look at the range of answers that we've got, and maybe this is why I think answer C might not be quite accurate enough for us. 11,688 feet actually fits within two answer brackets that we've got here. Yes, it fits within C, between 11.9 and 11.2. It also fits within D, 11.5 to 11.7. I'm going to say that C is a misprint and that actually it is answer D that we want. How did you find that question? Let's have a look at the answers. Yeah, answer D, 11,500 feet to 11,700 feet. By all means, go and check that question out on AvExam. It's number 23217. I couldn't find it on ATPL GS, and on ATPL questions, it's 616065. Okay, let's move on to the next question. This question says, you plan a flight over a mountain range at a true altitude of 15,000 feet above sea level. The air is on average 15 degrees colder than ISA. The pressure at sea level is 1003. What approximate indication should the altimeter read when it is set to 1013? Okay, there's a few different things going on in this question. We're probably going to make this the last question. I think by the time we've got to the end of this, you'll be able to go away and tackle other true altitude questions in the banks to reinforce your own understanding of how this works. Okay, so as always, let's start with our ISA deviation. So fair enough, it tells us that we are ISA minus 15. Easy enough. Let's set the rest of the page up. Well, we want to maintain a true altitude of 15,000 feet. We've got a QNH of 1003, which is 10 away from our QNE level. And because that is lower than 1013, our QNE, our 1013 is below the surface. And that is going to be 10 hectopascals, which means 270 feet. And okay, there's one thing that is missing in this question. In all the other questions that we've looked at, we've had an elevation for the place that's been giving us our QNH. It's very difficult to do a temperature error correction if you don't have the height of the parcel of air that we're flying over. That's kind of frustrating. Normally we would do 4 times height above surface over 1,000 times our ISA deviation. And this time we just can't do that. But you may remember that there is a second formula for working out temperature error correction, and it's a method that some of you probably prefer already anyway, and that is the 4% rule. In other words, for every 10 degrees of ISA deviation, there's a 4% temperature error correction. So we can use that one instead. So if we've got 4% per 10 degrees, well this time we're 15 degrees, happens to be minus 15 degrees, and 15 is 1.5 times larger than 10, so we can multiply 4 by 1.5, and that will be 6. So this time we're looking at a 6% error correction. Okay, how do you do that? Well, let me explain this. If you already know this, great. Otherwise, humour me for a moment. We can set our true altitude formula up because we know we're looking for a true altitude of 15,000 feet. And 15,000 feet will therefore equal our indicated altitude plus our temperature error correction, which in this case is -6. -6%. Well, when you start off, okay, humour me. If you bake a cake, when you take it out of the oven, providing everything's gone okay in your baking skills, which are not being tested on here, you come out with a whole cake, yeah? Well, think of our indicated altitude like that. You start off with 100% of your cake, in this case your indicated altitude. What we want to do is now cut a slice 6% off of that. So another way of writing percent is we could say 100% is 100 over 100 of our indicated altitude, and we want to take away 6 over 100 away from that in order to get our 15 15,000. Well, if we do that maths, we end up with 100 minus 6, which is 94 over 100. And another way of writing 94 over 100 is 0.94. So 15,000 feet is 94% or 0.94 of our indicated altitude. So to get rid of that, we can divide this side by 0.94, and if we do it to one side, we've got to do it to the other side. And so what we come out with is that our indicated altitude is 15,000 feet over 0.94. And if you plug that into the calculator, you end up with 15,957. Okay. So our indicated altitude is going to be 15,957. But remember, that is not yet adjusted for the fact that we've got a different QNH to our QNE. You can't just stop there, unfortunately, with this question. We also have to take into account this extra 270 feet that we've got because of the difference between QNH and the setting that we're actually on. So we need to add 270 to that. So plus 270 will give us 16,227.4. 16,227 feet is the indication that our altimeter will read in order for us to maintain 15,000 feet. Let's look at what the options are, and well, we're pretty close to option B. A would be 15,690. 16,230 is B, 14,370 for C, or 13,830 for D. It's B. I'm going with option B this time. So answer B is 16,230, and I hope that's what you've come to as well. The 4% rule is not one that I've majored on as I've gone through this. I prefer using the height above surface. I prefer being able to draw it and see it on a diagram. I'm a bit of a visual learner like that. If you're like me and you prefer the height above surface method, just remember that the 4% rule exists so that you can get it out of your back pocket just in case a question comes up where you need to put it into play. I'm going to leave it at that. I think you've now got enough in your arsenal to go and attack some of these questions in the question bank, and I'm pretty sure that you've got what you need to be successful in these exams, and that's what it's all about. Yeah, thank you very much for watching. I hope it's been helpful. If you've got comments or questions, then leave them in the comments section below. Also ideas for future ATPL tips series, that would be really great. Give me a thumbs up if you found this helpful, subscribe if you're not already, and yeah, thank you. I'll see you next time with some more ATPL tips.